Okay, class, we need to start over with completing section 2-3. Again, we're on page 141, and we go here to problem number 1. It says the point where any graph crosses the y-axis is called the y-intercept for the graph. Write the coordinates of the y-intercept for the graph that you drew. More importantly, what information does the y-intercept represent? So we go back here to page 138, and we look here at the graph. What this point is. This point here is 0, $5.10, and that is the y-intercept. So we will put the ordered pair here, 0, $5.10, because remember, with the y-intercept, that's when x is 0. And what it tells us is the cost of starting the ride in the cab. So this is the cost of starting the ride in the cab. I should put is $5.10 because that would tell you how much it costs. Because when you start the car ride, you haven't traveled any miles yet. Okay, number 2. How much more will you pay for a 3-mile ride than a 2-mile ride? So if you go back to the table on page 138, 3 miles is $12.90. 2 miles is $10.30. So we would take the $12.90 minus $10.30, and that gives us $2.60. Now it says, how much more will you pay for a 5-mile ride than a 2-mile ride? Explain why that makes sense based on your answer in question 2. Okay, a 5-mile ride, if we go back here to page 138, is $18.10. A 2-mile ride, we already said, was $10.30. So $18.10 minus $10.30 gives us $7.80. And it says, explain why that makes sense based on the answer to question 2. Now, this makes sense because we traveled 3 more miles, and so we should pay 3 times the cost of traveling 1 mile. Okay, so with that being said, we could put this in our calculator so we could take a look at this. Remember, 1 mile in the previous question cost us $2.60. We're traveling 3 extra miles. So we would take this and multiply it by 3, and it gives us the $7.80. So it makes sense. So now problem number 4. It says pick any 2 points on the graph that you drew and subtract the second coordinate. Then divide the result by the difference of the first coordinates for those same points. What does the result represent about the car ride? Okay, so why don't we do this? Since we know that this is the 2-mile ride, we could do 2 $10.30. We know this 1810 is the 5-mile ride, so we could do 5 1810. So we have our 2 points here. Now what they want us to do, they want us to take this $18.10 minus $10.30 all over the 5 miles minus the 2 miles. And this will give us $7.80 all over 3, which is $2.60 per mile. And then it says, what does the result represent about the car ride? That every mile cost $2.60. That's what it represents. Now we have here at the bottom, it says, for any 2 points on the line, x1, y1, well, x sub 1, y sub 1, and x sub 2, y sub 2, the formula below, which compares the change in height to the horizontal change, is called the slope of the line. It's usually represented by the letter M. So what we basically did here was the slope formula. When y represents some quantity, like the cost of the cab ride, the slope tells us the rate of change of that quantity. Now, when I say y sub 2 and y sub 1 and x sub 2 and x sub 1, what that is telling us is basically where to pull the numbers at in the ordered pairs. And I'm going to write this down here so you can see what I am talking about. Okay, remember we had two $10.30, and then we have five $18.10. Okay, so when we had these two, the x sub 1 and x sub 2 and y sub 2 and y sub 1 goes like this. We know an ordered pair is x and y. We know that. The sub numbers tells us where to get these values from. For instance, y sub 2 means go to the second coordinate and take the y value, which we did here. Y sub 1 says go to the first coordinate and take the y value, which we did here. X sub 2 says go to the second coordinate, take the x value, and x sub 1 says go to the first coordinate and take the x value, which we did. That's what it basically tells you, which coordinate to grab your values from. Okay, now we go here to the back for number 5. It says estimate the distance of a $16 cab ride. You can use either the table or the graph, but make sure you explain how you got your answer. Okay, now, if you look back on page 138, and we're looking at the $16 car ride, if you look here, between 4 and 5 of the table, you got 1550 to 1810. So it'd have to be a little bit over 4 miles. And it's based on the table. So it's a little over 4 miles based on the table. Now number 6, it says estimate the cost of 2.5 mile cab ride. Again, explain how you got your answer. Okay, well, let's take a look here. We have from 2 miles to 3 miles. So we want what's in between that. Now, remember, we said earlier for every mile, you pay $2.60. So if we're at the halfway point between 2 and 3 miles, first of all, we would take this $2.60 and divide it by 2. So that means we'll pay $1.30 for half a mile. So 2 miles was $10.30. And then we would add on $1.30 because that's halfway between a whole mile. So that would give us $11.60. That's how much we're supposed to pay. Now it says explain how you got your answer. You could just say, I took half of the $2.60 per mile and added that value to the cost of a 2 mile cab ride. Now, number 7, it says we know that the cost of the cab ride is going up by $2.60 for each extra mile. So how much would you pay strictly for mileage if the ride is 10 miles? Now, they said strictly for mileage, and they say ignore the $5.10 you pay just for the privilege of getting into the cab. So we would take this $2.60 and multiply it by 10, and that'll be $26. Now, number 8, how much would you pay strictly for mileage if the ride is X miles? Refer to question 7 if you need help. If you're really desperate, ask your professor. Okay, so basically, if we were doing strictly miles, it'd be $2.60 times some unknown value, or 2.60 times X. But for the sake of what we're going to use this for, you'll just write 2.60x because it's assumed to be in dollars anyway. So you don't have to write the dollar sign. Okay, number 9. Now the key question, given that the initial fee is $5.10, and on top of that you pay for the mileage as described in question 8, write an equation that describes the cost of a cab ride. Y in terms of the number of miles driven, X. So basically, we have Y is equal to 2.60x plus the $5.10 you pay just to get into the cab. Now it says, how could you use your equation to check your estimate of the distance of a $16 cab ride? Do it. Okay, so basically, when you take the mileage plus the initial cost, when you add these two up, we're asking that it equals $16. So we would take 16 is equal to 2.60x plus $5.10. So we would subtract 5.10, and that would give us 10.90 is equal to 2.60x. We divide each side by 2.60, and then we will have x, and we'll put this in our calculator. So we have, what's that, 10.90 divided by 2.60. And then we can round that to 2 decimal places. Well, 1 decimal place. So we'll make that approximately 4.2 miles. So that is a little over 4 miles. Okay, now we go here to number 11. How could you use your equation to check your estimate of the cost of a 2.5 mile cab ride? Now remember, looking back here at our formula, X is the miles, Y is the total cost. So since X is the mile and we have 2.5 mile cab ride, we'll substitute in 2.5 for X. So we have Y equals 2.60 times 2.5 plus 5.10. So we can put that in our calculator. We add 2.60, then a parenthesis 2.5, and then plus the $5.10. So that'll give us $11.60. All right, now we move on to the next page. And these are the last problems. Okay, it says writing the equation of a line. It says when a line has slope m and the second coordinate of its y-intercept is the number b, then the equation of the line is y equals mx plus b. And we know that's slope-intercept form. Now number 12. A small business had 12 employees when they opened their doors, but have been adding employees at the rate of 4 per month since then. Write a linear equation that describes the number of employees in terms of the number of months after the company was founded. Okay, first of all, we have to take a look at what we have. They say we started off with 12 employees. That's equivalent to saying that we had 12, we had the $5.10 in getting in the cab. Okay, so when we had our y equals mx plus b, we didn't write it out quite like this, but this is what it was. Our original equation from the cab was 2.60x plus 5.10. So this is what we're going to do. We're not going to reinvent the wheel. What we're going to do, we're going to basically do some substitution here just to show that we know what goes where. This $5.10 was the initial cost of getting into the cab. This 12 employees is the initial amount of employees that you had. So we know we will have plus 12 because that would be our B. It's the initial amount of employees, so it'd be plus 12. Now they tell us that we're adding employees each month at the rate of four per month. So it's $2.60 per mile. So this is 4 employees per month. So it'll be 4 times some unknown number. So basically we use the same skills that we used here in order to get this value here. So this right here is the equation for problem number 12. Now that is basically it because they did not ask us to explain this. So this right here is our final answer. All right. Now it says for 13, use a graphing calculator to create both a table of values and a graph for the equation you wrote in question 12. The technology boxes on page 144 will walk you through this process. Now, on Desmos, I want to show you how to do this on Desmos, but I need to expand this screen. What we would do here, we would type in the equation. We would have y is equal to, and you could type this on your computer's keyboard, y is equal to 4x plus 12. Okay, now we could zoom in so we can see this graph here. Okay, so we see the graph. All right, now it says they want us to do both tables and values and a graph. So we see the graph. But in order for us to do a table here, we would click on this wheel here, and then you will click on table. Now when you click on table here, it gives you values that will show up here on the graph. So as you see, let me get rid of this keypad. As you see, this gives you the table, this gives you the graph. And this is how you would do it in Desmos. All right. Now that that is taken care of, we're going to move on to section 2.4. And that is on page 151. Now, it says here on page 151, lesson 2.4, our title is The Great Tech Battle. And our objectives is to decide if two data sets are linearly related, find lines of best fit for data using spreadsheets and calculators, and also use lines of best fit to analyze data and interpret correlation coefficients. Now, one thing I didn't do, because technically this class we're using the Desmos calculator, but there may be some of you that still use the TI calculator. So what I want to do, I'm going to show you how to do that problem we did here, which was the y equals 4x plus 12. I'm going to show you how to do that on the TI-84 calculator as well. So let me pull the calculator up. Okay, so what you would do with the equation, you would first go to y equals and then type in the equation. It already gives you the y equals here. So you would do 4x plus 12. And then you'll press graph. Now it shows you the graph here. But then we also want a table. You will press second and then graph, and it gives you a table of values. So this is how you would do it in a TI calculator. Okay, now getting back to section 2.4. We'll go down here to the bottom. It says here in lesson 2.3, we examine the relationship between time of day and outside temperature. While we needed to study data to model the exact nature of the relationship, it doesn't exactly take a genius to figure out that the two quantities are related in some way. There are many quantities that seem like they might be related, but it's not clear that they really are. Or if so, how? So it would be nice to have a way to study relationships, if they even exist, between data sets. Fortunately, the lovely folks that program spreadsheets and graphing calculators have done most of the heavy lifting for us. Still, in our continuing quest to not rely on technology more than our brains, it's a good idea to think about when quantities are likely to be related in some way. Number one, decide if you think the two quantities are likely to be related in some way and explain your answer. Dollars spent by a political candidate and the number of votes he gets. I would say yes. Campaign spending can influence votes. Now B, an adult tests subjects' height and their IQ. Be like, no, there's no reason to think height affects IQ. C, a person's height and their shoe size. I would say yes, it is reasonable to think tall people will often have larger feet. D, the age of a car and its resale value. You like, yes, most cars are worth less as they get older. Okay, now we move on here to the next page and we look here at problem number 2. It says, is there a relationship between the total fat in a fast food sandwich and the total calories? Begin your study of this question by drawing a scatter plot based on the table. Okay. So we have our values here. We have our grams of fat, which we see here in the legend, which will be our X value. And then we have our calories, which will be our Y value. Now, they want us to draw a scatter plot. Okay. So basically, they just want us to plot these points. So first we would do 9 and 260. Now, just to give you a little background here, down here on the x-axis, they're actually going by ones. The y-axis, they're actually going by 20s. And these are not negative numbers, even though it looks that way. So now we had 9 and 260. Now our next value is 13 and 320. 13 and 320. Then we have 21 and 420. Then we have 30 and 530. That'll be in between 520 and 540, like real close to the middle. 31 and 560. 31 and 550. And then we have 34 and 590. 25 and 500. 28 and 560. 20 and 440. And then 5 and 300. All right, so we plotted all of these points here. Okay, so now for number 3, it says the points on your scatter plot don't form a straight line, but there should be a linear trend you can observe. Use a straight edge to draw a line that you think looks like the best fit for your scatter plot. Note that it's possible that the line that fits the data best doesn't go through any of the points. Okay, so now let me get a straight edge here. I actually don't have a ruler, but I'll just use this here. I think this might be the best. Yeah, okay. So that is my line. Now your line might be a little different, but that's fine. Okay, so now we move on to our next page. Now we look here at this tan box. It says a procedure for finding the equation of a line through 2 points. It says find the slope using the slope formula, difference of y coordinates divided by difference of x coordinates. Step 2, substitute the slope and the x and y coordinates of one of the points M for x and y in the equation y equals mx plus b. This results in the equation you could solve to find b. Okay, number 4. It says pick 2 points on your line. Watch out, don't pick points from the table or the scatter plot. Actually look at the line you drew and find points on the line. Write your points here. Now, your numbers could be different from mine if you did this on your own, but look in here and I'm going to base this on my graph here. I'm going to take this point here because it's exact. So that'll be 15, what's that, 360? Yes, 15, 360. Let me see if I can find another exact value. Now this looks exact here. So that'll be 180. Wait a minute. Let me look at that a little closer. Yeah, 180. All right. So I have 2 points from off of the line that I drew. All right. So now they want us to find the slope. So we know here this is x1, y1, x2, y2. So we will have the slope is equal to y2 minus y1 over x2 minus x1. y2 is 180, y1 is 360, x2 is 2, and x1 is 15. So this would be a negative 180 all over a negative 13. So we know that would end up being a positive because a negative divided by a negative is positive. So we could do, I guess I could use this here. This would be a negative 180 divided by a negative, 13? So let's round this to 2 decimal places. So it'd be 13.85. Now it says pick one of your points from question 4 using y equals mx plus b. Substitute in your slope for m. the x coordinate of your chosen point for x, and the y coordinate of your chosen point for y. Solve the resulting equation to find b. What does it mean? Remember, b is the y coordinate of the y-intercept. So I'm going to pick the 2 and the 180 because they're smaller numbers. So I have y equals mx plus b. Now we know what m is. M is the 13.85. But now we have x and y. Y would be 180. The m would be 13.85. The x would be 2 plus b. So it'd be 180 is equal to, what's that? That'll be 27.70 plus b. We'll subtract 27.70. So 180 minus 27.70 will give us 152.30 is equal to b. So now they ask us to solve the resultant equation to find b. We did that. What does it mean? Remember, b is the y coordinate of the y-intercept. What this actually means is that there are 152.30 calories in a sandwich with 0 grams of fat. That's what that means. All right. Now it says, use your answer from question 5 and 6 to write the equation of the line you drew in the form of y equals mx plus b. So it'll be y is equal to, the slope was 13.85. Then we have our x plus b will be 152.30. So that will be our equation. Now, we move on to the next page. So now we have problem number 8. It says, use your equation to predict the number of calories in a Whopper, which has 39 grams of fat. So we have y is equal to, we know it's 13.85x plus the 152.30. That would be our equation. Now we're going to substitute in 39 for x. So it's 13.85 times 39 plus 152.30. So 13.85 plus, I'm sorry, supposed to do multiply, times 39, and then plus the 152.30. So we get 692.45 calories. All right. Now it says, so far we've used our eyeballs and perception to draw a line that we think fits the data best. Then found an equation for that line. But is your line the line of best fit? There's a pretty good chance that everyone in the room drew a slightly different line and has a slightly different equation. Graphing calculators are programmed to take all data into consideration and find the line that best fits the data. That line is called the line of best fit, which is not the most creative name ever, but is descriptive. Okay, so we're going to do this on Desmos, and also, if I have time, I'll do it on the TI as well. It says, use the procedure in the using technology box to find the equation of the line of best fit using a graphing calculator around the 1 decimal place. Okay, so basically what would end up happening, we will first have to go back. Let's go back to page 152 to this table. we need to type in this table here. So we would add a table and we'll type in these numbers. So we had what, 9, 13, 21, 30, 31, 31, 34, 25, 28, 20, and also 5. Now, we go here on the other side to type in the Y values. It's 260, 320, 420, 530, 560, 550, 590, 500, 560, 440, and also 300. Okay, now we typed in all of these values. Let me expand this out a little bit. Okay, so we have all the values. Now our next step, and I need you to pay close attention to this. We know the equation is y equals mx plus b. We already know that. We've been working with that so far. But we have to type this in a little differently in Desmos. So what we would do first, if you look here at this table, you got y1 and x1. So the first thing you would do for y, you would hit y and then the number 1. You see how it's subscripted already. Then you will hit this ABC, and you have to hit what is called the tilde. Then you will hit MX, and then you'll put 1, because up here, remember the X has X of 1, and then you will put plus, and then B. Now, with this equation here, it gives us its slope, it gives us the y-intercept. So now, let me put that in. So they ask us to find the line of best fit. So it'll be y equals, the m will be 11 point, we did 2 digits, so it'll be 11.73, if we round to 2 decimal places, x, plus 193.85. So that is the equation of the line of best fit that we have here. Okay, so now, with that being said, we go to problem 10. It says, use your answer to question 9 to predict the number of calories in a Whopper which has 39 grams of fat. How does the answer compare to the number of calories predicted by your own line of best fit? The actual number of calories in a Whopper is 660. Now, when we actually did this, we came up with 692, so we was like 32 above it. So let's go here, and we're going to substitute in for the Whopper. It's y equals 11.73 times 39 plus 193.85. So now we need to put this in our calculator. We can put this in Desmos. So we have 11.73 then times 39, and we're using a parentheses as multiplication, plus the 193.85. So that gives us 651.32 calories. Now it says, how does the answer compare to the number of calories predicted by your own line of best fit? So we could say that my line is, what's that, 42 or 40, well, it'll be 41 more calories than the calculators. Okay. All right. So it says, when finding a line of best fit using a graphing calculator, the line in the display should be a value for a quantity labeled R, which is known as the correlation coefficient. This number measures how well the line seems to fit the data. The closer R is to 1, positive slope, or -1, negative slope, the more accurately the data you enter can be modeled using a linear equation. Here are some examples based on data from 2 of my classes last semester. Okay, so it says here, one of these scatter plots has a correlation coefficient of 0.12. The other has a correlation coefficient of 0.72. Discuss which you think is which and why. Okay, basically, the higher the R is, whether on the positive or the negative side, the higher the R value is, the closer it is to looking like a line. So basically, when we look here, we have to ask ourselves, which one of these looks more like a line? So this one does. So we could say that the first graph is R equals 0.72, and the second graph is R equals 0.12. All right, now, and if you look here, remember, this is a positive trend and it's more like a line here. All right, so we go back here to number 12. It says one of the scatter plots has each student's homework score for the semester on the x-axis and the corresponding overall percentage in the course from 0 to 100 on the y-axis. The other again has overall percentage on the y-axis, but along the x-axis is the student's position alphabetically in the class. The student whose name comes first alphabetically is 1. The next alphabetically is 2, and so on. Which plot is which? Label the x-axis for each graph. Again, discuss your reason. Okay, this first graph would be more so the homework score, and the second graph would be the alphabetical position. Okay, now, the reason being is this here. With the homework score, you notice here that the scores start off small and then they go up. So this is the homework score, and then this is off of the alphabetical position, because they're all basically going to be around the same area for the alphabetical position. But now, it asks us to write out a statement. We could say the first is homework. It's basically the homework score, because that is more likely than alphabetical position to show a linear relationship with overall grade in the course. Okay, now we look here at problem 13. It says, what is the value of the correlation coefficient R for the fast food sandwich plot? Round to 2 decimal places. Now we have that here. It automatically showed up R. It says the round to 2 decimal places is 0.97. Okay, Now, I did want to show you all this in the graphing calculator. So let me get to that. Show you this in the graphing calculator real quick. So first thing you have to do is to go to the, well, we have to go to stat and press enter. And then that gives us L1 and L2. So again, you will press stat, press enter, give you L1 and L2. L1 represents the X values and L2 represents the Y values. Okay, so now what we're going to do, we're going to go back to page 152 and we need to type in the X and Y values here into this calculator. So we had 9, 13, what's that, 21, 30, 31 twice, 34, 25, 28, 20, and then 5. So we had 260, 320, 420, 530, 560, 550, 590, 500, 560, 440, and 300. Okay, now we put all these values in. Now we're trying to get the same thing. We want to get the slope and the y-intercept, so we will be able to do our equation. So what you will have to do to get that, you have to go to second. Oh, you know what? No, you'll press stat and then go to right to calculate, and then you will go down to number 4, which is the linear regression. Press enter. Now listen, when you get here, you got to make sure that your X list is L1, your Y list is L2, and then your frequency list and the stored regression equation, both of these need to be blank. So you'll go down here to calculate, and it will give you the values. Now, instead of using mx plus b, they use ax plus b, but a represents your m. And it's 11.73 if we round, and then it's 193.85 if we round. So this did give us those values. Now, here's the issue. If your calculator is like mine and you don't see the r or the r squared, what you need to do in order to get the r or the r squared is press second 0 to catalog. Then you will go here to this x to the -1 key, right where I'm pointing at. Hit that and that'll take you down to the D's. Now you will scroll down until you get the diagnostic on and press enter twice. And you should see the word done. Once you do that, you can go back to stat, go to calculate, go back to the linear regression, press enter, and now your R's show up. And if you rounded this to 2 decimal places, it'll be 0.97. So this is how you would actually do it in the TI calculator as well. All right, now, oh, you know what? Okay, so now we're going to move on. And we're going to move, actually, it says problem 14, use the procedure in the using technology box to find the equation of the line of best fit and correlation coefficient. Okay, we're not using the Excel portion here, so we won't do problem 14 and 15. but we will go on to page 158. And we'll look at problem number 1. Now we'll discuss problem number 1. It says, do you think there's a strong connection between a person's shoe size and their height? Answer yes or no. Explain why you feel that way and make a guess as to the value of the correlation coefficient for these two data sets. Now, the thing about it is we were supposed to be in our classroom and ask students, their height and their shoe size. But obviously we can't do that now. But what we can do is talk about the fact that since I would say based on our life experience, we've seen that most of the time taller people have larger shoe sizes, even though there are some exceptions to that case, but most of the time that is typically the case. Now we're going to move on to page 160. And this will be actually, if I am not mistaken, this is actually the last part of section 2.4. Okay, now it says Olympic men's long jump. It says the table to the right shows the gold medal lengths for the men's Olympic long jump for selected years from 1900 to 2000. When dates are part of a data set, it's common to not use the year, but rather the number of years after the first date. This allows for smaller numbers in the calculation, which can reduce the amount of rounding error. So we look here at number 10. It says use a calculator or spreadsheet to draw a scatter plot for the data with the number of years after 1900 on the x-axis and length on the y-axis. Then find the equation of the line of best fit. Round coefficients to 3 decimal places. Okay, what they did here, they set this up for you. These are the years, and these are the years now represented since 1900. So 1900 would be 0, and then all of these other years go comparison to 1900. So now we want to put this in our calculator. I'm going to put this in Desmos. And you could feel free to put it in Desmos if you choose. All right, so we have 0, 12, 20, 32, 48, 60, 72, 80, 96, 100. So we have 7.18, 7.60, 7.15, 7.64, 7.80, 7.82, 8.12, 8.24, 8.54, 8.50, and 8.55. All right, now we have all these values in. So now we're going to type this in so we could get our equation. It'll be y1, the tilde, mx1 plus b. And then we have our equation. So our equation would be, let me write this down. Our equation, you know what? I made an error here. And this is good too. Okay, look here at this table. This table has x2 and y2, not y1 and x1. So it should have been y2 and x2. And then we will have our equation. Now, our equation will be y is equal to, we could round to 2 decimal places, or make it 3. 0.015x plus 7.179. That is our equation. It says find the slope of the line. What does it mean? The slope is a value connected to x. So the slope is 0.015. And we could say the long jump increases each year by 0.015 meters, because that's in meters. Okay, number 12. It says the second table lists the lengths of winning jumps for some years not in the table. Use your equation to find the predicted length for each winning jump. Okay, so now what they want us to do with this, with our new equation, they want us to put in the values here. So I'm going to show you a little trick with Desmos that you could do that'll make this a little easier. Just first type out the equation that you had, which is y is equal to 0.015x plus 7.179. Okay, that's the equation we have. So we can hit this wheel here. And what we could do, we could hit the table. And when you hit the table, you see that values are generated here. So all we have to do now, let me make this a little larger. Okay, all we have to do now is just type in the values that they're asking us for. Now on this page, these values are the X values. So let me type those in. We will have 84. And then we will have, what's that, 104, 108, and 112. All right, now, because I got this graph just a little, let me see if I can make this a little bigger. Okay, good. All right, so we can round this to 3 decimal places. For number 12, it says the second table, so we want to put the predicted values. Now, what I typically do when I put the predicted values, I typically will put them over here, right next to the actual values. So for 84, it was supposed to be 8.439. 2004, it was supposed to be 8.739. 2008, 8.799. And then 2012, it was supposed to be 8.859. Now it says here, how do the predictions compare to the actual jumps? So basically after 2000, the equation is over predicting. By quite a bit. Okay. All right, 14. It says, use your equation to predict the year that the men's long jump record will reach 9 meters. Remember, the Olympics are only held every 4 years. Okay, so basically they want us to take our equation and then we'll substitute in 9 for y. Now, so we had 9 is equal to 0.015x plus 7.179. We'll subtract 7.179. So this will give us 1.821 is equal to 0.015x. So we have 1.821 equals 0.015x. Divide each side by 0.015. And then we will have, we're going to have to approximate this. So we will have actually 1.821 divided by 0.015. So it'd be 121.4. So basically it says, now it's supposed to be in the year 2021. So it's supposed to be in the year 2021, but for the Olympics, it would be 2024. Because remember, the Olympics is held every 4 years. Okay, now 15. Do an internet search for 1968 men's long jump. After reading about the event that year, explain why we purposely left that year out of the table. Okay, I'll tell you why. The winning, and you can look it up, the winning jump that year was an outlier that would throw off the trend. There'll be an outlier that would throw off the trend because it was so high back in 1968. So that basically covers 2, 3, and 2, 4. Now remember, you have to do your check assignment tonight for 2, 3. 2, 4's check assignment would not be available until Monday. All right, have a wonderful day, a wonderful weekend, I should say.